So they also want us to find z1 divided by z2, and we already know how to do z1 divided by z2. You just divide them. And then you're like, I don't really like that imaginary number in the denominator, so I'm going to rationalize this guy, because I is like a square root, right? It's like a square root of -1, so I want to get that guy out of there. So I'm going to multiply top and bottom by the conjugate. Pretty things should happen to the bottom. 1 times 1 is 1, then I have plus I, minus I, and then minus I squared. So the middles go away like we planned. That's the beauty of the conjugate. And then we have 1, I squared is -1, so -1 is +1, so it's basically +1. So 1 plus 1 is 2. And then if we multiply the tops together, we get root 2 plus I root 2 minus I root 2 again, so, and then minus I squared root 2. And I squared is a -1, so basically this is positive root 2. So if I add root 2 plus another root 2, I get 2 root 2. And then the middles are going away, it looks like. Root 2 plus I root 2 minus I root 2. Okay, so the middles are going away. And then we're just going to get 2 root 2 over 2, which is just root 2. Alright, so we're going to have a chance to check this when we do it our other method. So this was our old method. This is not the method that they wanted us to use in this chapter, but hey, it wasn't that bad, and it made sense. We just divided it. Our new method is with the polar form. So remember in the last video, we did our polar forms for both of them, and we got that z1 was cosine 7 pi fourths plus I sine 7 pi fourths, and z2 was root 2 cosine 7 pi fourths plus I sine 7 pi fourths. So these were our trig forms of those. And so our rule says that if we're dividing things in trig form, I can go ahead and divide their radii, so 2 divided by root 2, and then subtract their angles. So if I do 7 pi fourths minus 7 pi fourths, that's 0. So I'm getting the cosine of 0 plus I sine 0. And the only thing I might want to do to this is rationalize that thing. So if I have 2 over root 2 and I multiply top and bottom by root 2, I get 2 root 2 over 2, which is just root 2. So I've got root 2 times the cosine of 0 plus I sine of 0. And believe it or not, that's what they want for your polar form. And that's how they want you to leave it. Now to check to see if this answer matches the answer we got with our old school method, all you have to do is convert it to standard form. Cosine of 0 is the same thing as 1, and then the sine of 0 is the same thing as 0. So I do indeed get root 2 when I simplify that. So woohoo! They match. And again, it's like, oh God, seems like a lot of rigmarole. Why? But we will see why in a second.